exponents. Exponents are also called powers, aka powers. And it looks like this. I will jot you down one. Exponents are those little things when you see numbers and that little number that gets put in that upper right-hand corner. That number right there is the exponent, or its power. And the big number here on the bottom there we call the base number. And does anybody know what 5 to the second power is? Evelyn?
25.
It is 25. And write this down here. What the exponent tells you is this. The exponent tells you how many bases get multiplied together. That's the big hitter right there. How many bases get multiplied together? So, like Evelyn was saying, this 2, that exponent says that you multiply 2 5s together. 5 squared is 2 5s times themselves, and that is 25. If it would be 5 to the third power, by the way, if it's a 2, we call it a square. This is 5 squared. It's the same thing as an exponent or power of 2. If it's 3, we call it cubed. So if you hear those words squared and cubed, okay, cubed means 5 times 5 times 5. Now please be very careful. One of the big mistakes I see with people is they start doing 5 times 3, but this is not 5 times 3. 5 times 3 is 5 plus 5 plus 5. 5 times 5 times 5 is 5 times 5, which is 25, times another 5, which is 125. And then 5 to the fourth power would be 4 5s times themselves. And 4 5s times themselves would be, anybody? If it's not 20, please don't tell me 20, because that's 5 times 4.
What is 4 called? Because 3 is
There's
cubed.
no, you just say 5 to the fourth power. 4 doesn't have a special name. 3 is cubed, 2 is squared, everything else you just say to whatever power. Connor?
500.
Well, unfortunately not.
510.
No, 625.
Oh, I did that wrong.
Okay.
How do you multiply that? 5 times 5.
Well, it's just 5 times this number,
Oh, okay.
which is 500 plus another 125. I'm just doing, you don't need to know these, but what I want to show you is this. If you do 5 to the fifth power, that's 5 times themselves. Okay, you end up with 3,125. If you ever hear the phrase that something grows exponentially, that is because of this. 5 times 5, 25 is not a very big number. 5 to the second power isn't very big. 5 to the third power, 125, it gets a little bit bigger. 5 to the fourth power, now you're starting to get into 600s. Here you're in the 3000s. If I go 5 to the next power after that, I'm going to be in the 15,000s. And the next power after that. And exponential growth means this. Just like 25 wasn't very big and 125 wasn't very big, but the farther out and the higher you get, the quicker it gets going really, 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 really fast. And another example would be like 2. If you have 2 to the second power, 2 to the third power, 2 to the fourth power, 2 to the fifth power, 2 to the sixth power, 2 to the seventh power, 4, 2 times 2, 4 is not very big, and 2 to the third power, which is 4 times 2, 8, it doesn't seem like it grows that much, it's not that big. But 2 to the fourth power, if you multiply 8 by 2, you get 16, it gets a little faster. 2 to the fifth power is 16 times 2. 6th power is 64. Now it's starting to grow a lot faster. The 7th power is 128. To the 8th power, it's going to be 256. To where eventually it grows, it just starts growing faster and faster and faster. Exponential growth is growth that doesn't seem to grow fast right away, but then as you get going, then that goes really, really, really fast. I don't know if they get to. Now the reason they give this to you is because they're going to ask you to do stuff like this. One thing to understand about powers is, especially with tens, what they mean. Tens are really easy numbers to put to exponents because it's just a matter of adding zeros to things. So write these down. Anything to the first power is itself, just kind of know that. 10 to the second power is, 10 times 10 is 100. 10 to the third power is 1,000. 10 to the fourth power is 10,000. What pattern can you see there? Where if we skip right to 10 to the seventh power, you should be able to tell me what it is or what it looks like. What is the pattern there, Carter?
Add a 0.
Well, add a 0 or just look at the exponent. Whatever the exponent is how many zeros you put after the 1. So if you were talking about 10 to the 7th power, it's 1 with 1, 2, 3, 4, 5, 6, 7 zeros after it. It's 10 million. 10 to the 6th power is 1 million. And the reason I believe they put this into this section is because they are going to have you write things in expanded notation with exponents of 10. Expanded notation with powers of 10. And I'll show you what that means. You will remember before when we did expanded notation, it looked like this. You would do 8 times 10,000, right? Because the 8 was in the 10,000s place. Plus 6 times 1,000 plus 3 times 10. Remember doing that? We probably still do it here. But now that you know exponents and powers, you're not going to waste quite as much time writing all this out because you're going to write it as an exponent or a power of 10. So this would look like this. You still have the 8 times, but this would just be 10 to the 1, 2, 3, 4th power. Plus, this will be 6 times 10 to the 3rd power. Plus 3, and you can either write times 10 to the 1st power or just times 10, it's the same thing. If they ask you to write it using powers of 10, you are going to do this instead of this. Okay? You're going to do that instead of that. Another example would be, how about if we do 1,200,200. In expanded form using powers of 10, I am going to have 1 times 10 to what power? Does anybody know? Bryce?
1 million? 6.
6, because there are 6 digits that come after the 1. Plus 2 times 10 to the what power? How many digits come after the 2? 5. Plus 2 times 10 to the, how many digits come after the 2 there? 2. Because this 10 to the 6th power stands for a million. 1 times a million, which gives me a million. To the 5th power stands for 100,000. 2 times 100,000 is 200,000. So the 2nd power is 100. 2 times 100 is 200. Perfect. Now, unfortunately, we got to do one more thing.